Question 3. We ask for the coordinates where the gradient is 1. The keyword is gradient. That means we have to differentiate. We're going to put the gradient as 1, so we substitute p-x for 1. Solve that equation. We find that x also equals 1 in this case. Put 1 into the equation to find out what the gradient is to get the coordinate. We want the y value as well. And so the x value is 1, the y value is -6. And that was for achieved. For this question here, we have a clock manufacturer. We're given the differentiated equation. We're told the daily fixed cost is 120, so we know the constant is 120. We want the actual equation, so we're going to have to anti-differentiate it. First of all, write it out again, and then go through and add the 1 to the power and put the x in and the c. We know the c is 120. That's given to us in the question. Tidy up the equation a little bit by dividing by 3 and 2. So there's the equation of the cost. Now we want the cost of 500 travel clocks. So substitute 500 for x, put the 500 in, run it through your calculator, don't make any mistakes, and there's achieved. And yeah, you might be pretty angry as well, all that work for achieved, but it was quite good fun really. Equation of the tangent. Differentiate to get the gradient of the tangent. We've got the point 1 there, so put 1 in for x, and this will give us the gradient. So the gradient of the tangent is -8. Equation is y equals mx plus c. We've got the points 1 and 4 and -8. Put them into y equals mx plus c. Solve for c. Write out the equation of the tangent. Get your merit. Move on to the next question. Here we want the gradient equals 28. We have our gradient formula from the previous part. Put 28 into there. Make it equal 0. Got a common factor of 6. Factorize the brackets. We've got x as being 2, -2 and 3. Now, we want the coordinates of the points. So we have to go back to our original equation and put -2 in there to work out the y value. So we've got the point -2, 1. And we're going to replace that -2 now with 3, because that's our second x value. So replacing it with 3 there, and we get 16. So those are the coordinates for the points where the gradient is 28. Here we've got a function, and we have to find the minimum points. Well, minimum means we're going to have to differentiate. Then we're going to make it equal 0. So multiply by the power, subtract 1 off the power. We also need to tidy it up a bit, make it equal 0 and factorize. And so we get our 3 points, x values are 0, square root of 2, and negative square root of 2. You could use decimal values, 1.3 something. If you got a bit stuck with that one, where did that square root of 2 come from? The second bracket has to equal 0. So just make it equal 0 to change sign, and you'll see that the square root of 2 will satisfy the second bracket, and the negative square root of 2. Now we're asked for the coordinates, aren't we? So put them back in the original equation to get the coordinates. So when you put the square root of 2 in, you get a value of 2. And also when you put the square root of -2 in, because they have even powers, the negatives cancel. It's going to be the same value. Don't worry about the 0. The 0 is actually the maximum point. Excellence. And for the last part of this question, expand out your differential equation, then you can integrate it. Because you're given a differential equation, integrate it. To integrate it, write out the equation, then go and change the powers, add 1 to the power, divide by the new power, add a constant. Now we're told that the function has a minimum turning point of -6. So the minimum's down there, maximum's at the top, so these are our turning points. The turning points are when the differential equation equals 0. So the minimum turning point is at the point 1 because we're going along the x-axis, and -2 along the x-axis will reach your maximum, and as you move along the x-axis the minimum will be at 1. So that's the point 1, -6. Put that into your equation for y, work out what the constant is, write out your equation, get excellence. Cool.